Hey YouTubers, welcome back to the shop. We had 3 videos up earlier on parting, facing, and turning on the lathe, and I went through 3 different metals and seemed to take forever, I guess. The other problem we had was the camera was flipped in the wrong way. So it looks like a rear left-hand lathe, as somebody put it. So we've corrected the problem with our camera. We're going to redo this video as a 3-parter. Facing, turning, and parting. And we're just going to use a piece of aluminum for this. This is like 7/8 diameter aluminum. Has a hole drilled through it because it used to be a muzzle brake. So first thing we're going to do is we're going to explain a few setup procedures here. First off, on my cutter I like to leave a little bit of overhang over here along the side, especially because I'm going to do facing with this at the same time. So I don't want it rubbing into the holder at all. Next thing we're going to do is we're going to square it up as best we can so we get the flattest possible result. Lock that down. My compound is already locked down, but it's going to be unlocked in a second. So we're going to go to here, right to the front of the face of the piece, and we're going to lock down the carriage. We're going to unlock the compound, back it out, go in a couple of thousandths. I'm going to do this at 970 RPM because you get a nicer finish. You get an even nicer finish at 1620. And we're only taking a little teeny bite at a time. What I'll usually do is I'll let it sit there for a second. Because if I've gone in too fast, I don't know what it is, but for some reason if I go in a little too fast on a face cut, it has a little extra it wants to remove. And there's still a little bit that's going to come off before that's perfectly flat. So what we're going to do is we're going to loosen off the compound, go in a couple more thousandths, and back at it again. Try and keep your feet consistent, keep it going. Okay, so we've got a really nice finish going on, nice and flat. There's no more sign that it needs any more. So we're going to unlock the carriage at this point. And we're going to bring the cutter right into the edge. Zero the dial, back it out. I'm going to take about 10 thousandths off the diameter, so it's going to be 5 on the dial, which is 10 off the diameter. And again, we're going to do this turning operation at 970. We're not using any fluids whatsoever. So with this small of a bite, it's not going to make a difference on your finish. Couple finish passes. Okay, now that's got a very, very nice finish on it. That's almost passable to just put on the shelf for sale. Almost. I like to buff them to a nice mirror finish. So I put that on the buffer afterwards. I won't take sandpaper to that. But in critical precision machining, you have to take the finish passes. You have to make an allowance for at least 1 to 2 thousandths on finishing passes so that you'll get to that exact precise diameter. There's no way around that, you know. Especially if you're going to do it at the precise diameter. You must take those finished passes. Otherwise, you're not going to have the smoothest surface, is basically the idea there. But I don't use the lubricants when turning aluminum. I rarely ever use them for parting either. Some guys are like, well, it'll turn out better finish. Well, you know what? Maybe it might, but the thing is for the stuff that I build all the time, my finishing off of my front face is always done with face cutting. So my main piece is always inside already, so I'm not worried about it, you know. So it's not a critical thing on that sense. So when I do a parting cut, I don't care if this side here is rough, because it's going to get re-flattened out. So when I make a muzzle brake, for instance, you know, I'll have a bar stock in here, I'll have it on the live center, turn down about, you know, 5 inches or 6 inches, however long the brake is. You know, if it's a short brake, then I don't use a live center. I'll free cut it, and I'll do it at really light passes, just because sometimes I have a little more hanging out than what I'm supposed to or should have. So if you take really super light cuts, it takes a little longer, but you can still get away with it. So there's a lot of things you can get away with that, you know, kind of bend the rules a little bit. Now, so we've got a face cut done. We've got our outside diameter turned, and we've got 2 finished passes on there. Looks really sweet. So now we're ready to do a parting cut. And our parting cut, we're going to do that at 210 RPM. Now, a lot of guys say, you know, when you're parting, you should go as slow as you can. The problem is with some metals, if you go too slow, they'll bind. Especially brass, it's a nasty one for it. If you go too fast with some metals, they'll bind, they'll burn out your cutter, etc. Now, I've never had wear and tear ever happen to me when using aluminum or brass as far as my cutter life goes. So it's not going to extend my cutting tool life any by using fluids to do a parting cut on aluminum or brass. It's not going to extend my tool life just by using fluid. It may make a nicer face or make it go a little faster, but I have the time, so I don't care about being a speed freak, you know. And besides, it's speed that becomes the problem in life, you know. Now what you want to do is get as close as you can to the chuck on any parting operations. The closer you are, the more rigid it's going to be. Your blade, you don't want it sticking out too far either, usually until it comes to the center area. That's fine, and your blade's going to be nice and rigid. Now this is a 3/32 blade, which a lot of guys complain about too, saying, oh, that's too thick of a blade for your machine. Well, that's poppycock, I'm sorry. I don't know where they get their information from, but 3/32 is more than adequate for this lathe. In fact, anything thinner, I would be scared shitless to use it, because it'd just be too flimsy, you know. So I prefer a thicker cutter to begin with, and it was also what was recommended even on my 7x12 lathe, was the 3/32 parting blade for this style of parting tool. And there are other types of parting tools too that are a lot more rigid too, and eventually I'm going to get a more rigid one just because, you know. And I'd like to try out those other tools. You know, I have some indexable stuff, some brazed on stuff, etc. But I'd like to try an indexable parting tool and see how much better they are. And I've ground some of my own too before, and you know, it's like, that's a pain. So anyway, on with the parting. So we're all lined up, everything's squared up. We're going to lock down the carriage for this, because we don't want it to move. Disengage your power feed for your carriage. Make sure it's disengaged down below too, so no accidents can happen. 210 RPM. We're going to take the feed rather slow. This is 7/8 diameter, by the way, in case anybody's wondering. Okay, so our parting cut is completed. And our piece is down there. We'll fish that out. Now, have this been the final piece, the next stage for this would be to put it back into the chuck and reface that. You know, our front across here is fairly flat, looks pretty good. Now, how flat really is it? Let's see how well it stands on its own. Oop. Get over here. That's actually pretty decent. Very nice. What I did have a problem with in those other videos, I took a really thin slice of brass and had a bend in it and had to pound her flat. Sometimes that does happen, and you know you have to kind of tap it down. And but it shouldn't happen in theory, but it does when you take a really super thin slice, and if you try taking the speed a little bit too quick, it can actually heat the brass up enough that it deforms. But also having your cutter off angle too. That was another problem that I discovered I did have, was my my parting tool was actually sloped a little bit. So I changed tool holders, and it turned out it was a bad tool holder, and that's why I had problems. So now we've cured that too, because we're getting some really nice flat work now. So it's actually a lot more acceptable than what it was before, and that I like. That's pretty good. I would still clean that up though either way, because that to me wouldn't be finished. To me, finished is nice and shiny and you know whatnot. So this kind of completes our little series of facing and turning and parting on the lathe. And you know, you got different feeds and speeds for different metals. There's no absolute when it comes to that, because the guides that you find that you can download off the internet and stuff, they're just that. They're a guideline. They're an approximation. They're not geared to every single machine out there that uses every single diameter that's listed. So it is a guide, and a lot of it is feel, you know, etc. And you know how rigid your machine is too may make a difference. Maybe you can get away with going at higher RPMs. I actually got quite comfortable parting 304 stainless steel at 350 RPM and using a lot of cutting fluid, and it worked really well for me and I liked it. But generally I'll do it a lot slower. Now as far as using cutting fluid when doing a parting cut on aluminum, it's really not necessary. It's not going to extend your tool life any. What's going to help is by taking the feed slower, we'll avoid having the need for flight coolant or even cutting fluid to do it. Just take the feed slower, that's all, and take littler bites. I mean, my average bite here, because I'm fairly consistent when I'm doing this on aluminum, you're looking at 7 thousandths at a time is all I'm taking off. You know, maybe 8 tops. So I've got a fairly consistent feed rate, and 7 thousandths at a time is actually really good. And not using any kind of cutting fluid, and to get the finish too, I mean, that still needs a lot of work on here, you know, as far as I'm concerned. I mean, I wouldn't sell that like that, you know, and this is the piece. So if this ended up being the piece, well then it needs a hell of a lot more work, you know. So, and I've tried it with cutting fluid, and it actually doesn't make all too much difference. Even turning operations, I take lighter cuts anyways with aluminum, so it doesn't get deformed, you know, because aluminum is basically, like, you know all about tinfoil, right? Well, it has a low melting point, so I like to turn them fast to keep the coolness down, and I like to take the cuts lighter, so I get a nicer finish in the end either way. So, and then there's not so much work to do on the buffer later, and I won't have to take sandpaper to it. And I do the same sort of thing with brass, except brass will actually, I'll do parting cuts with brass at a much faster speed rate, and same with my cutting. My turning operation, I usually do brass at 970. Stainless steels and regular steels, they get done much slower all the time. You know, either way, like we're talking 210, 350. And parting, I usually do at about 115 with steels and stainless steels. and I do use cutting fluid for the parting cuts for that stuff. Not too often though I actually use any kind of cutting fluid or anything else for a turning operation on steels and stainless steels, because it's not required at the slower speeds, and really it's not going to give me that much more of a benefit for the final finish, because not all metals finish nicely like mild steels won't. They actually require a lot of sanding after, so I usually leave about 4 thousandths left over on my final diameter. Then I can sand the hell out of the sucker to get a nice finish in the end. Some other steels that are mild steels but with a slightly higher carbon content will actually peel a lot nicer and smoother, and therefore they get treated differently too. And different diameters, you'll learn how to do them differently, right? You know, 2-inch aluminum, I'll actually still turn it at about 970. Parting cuts, I will go a lot slower. I'll usually go 115, 210 with 2-inch for doing a parting cut on 2-inch aluminum. You know, this is, I got a 1 disc here wherever it went. This stuff was actually started out at a full 2 inches. I don't know what it is at now, but it was parted off on the lathe. 1.754 inches. So if you want the metric equivalent, that's 44.55 millimeters in diameter, and that was done with a parting cut, and then I faced it off on either side, and till I got the identical thicknesses on each side, you know, and that worked out just fine, you know, and that was done on this machine too. So things are different, and it's what you get used to too. The more experience you get, the better you become, and the more you get to know things and know metals and what you can do with them and so on. So anyways, I hope you enjoyed the video. Sorry if it was a little bit long, and I try to get as much information there as I can, and we'll definitely see you next time, and stay tuned for more videos.